So let's move on to question 7. Question 7 reads as follows. All positive integers n for which n into n plus 1 into n plus 2 is a multiple of 5 are listed in increasing order. Okay, let's analyze that first. These three numbers are all consecutive. Each one is one more than the previous one, as you can see. And the product is a multiple of 5, which means that at least one of them is a multiple of 5. If none of these three factors is a multiple of 5, you cannot have that the product is a multiple of 5. So at least one of these is a factor. So you're looking for three consecutive numbers where one of them is a multiple of 5. Okay, so let's start with the very first 5 that you have is first multiple of 5 is that. So you have 4 that way. 5 can be at the end, or you could have 4, 5, 6. Or these are not being multiplied. It's a sequence. They're listed in increasing order. So these ends, if n equals 3, then 3 times 4 times 5 is such a number. So this is for n equals 3. When n equals 4, this is the second number. So all such numbers are listed. The next one will be 5 times 6 times 7. And then 6 times 7 times 8 is out. 7 times 8, 8 times 9 is out. But 8 times 9 times 10 is in. And 9 times 10 times 11. 10 times 11 times 12. So these are the numbers. Okay. Now, every one of these, I'm going to put them as a form of a sequence. So I think you have to do this here. 3, 4, 5. You're not going to repeat these. Then we put 8, 9, 10. And then 13, 14, 15. Like that. So they're all listed in increasing order. All these numbers have got the property. If you take any one of these and you make that value, make it equal to n, then you see that you got, for instance, 10 times 11 times 12 is a multiple of 5, 14 times 15 times 16, multiple of 5, and so on. Okay, So, so you can see what's happening here is that the third number is 5, the sixth number is 10, the ninth number is 15, and you got 2022, and the first three possible values of n are this. So this is the answer to A. But they want to know what is the 2022nd number in the list. Well, I've separated them in blocks of 3, like this. Because 2022 is actually 3 times 674. So the 674th group will contain this number. Not this number, this position. All right. So you got this position 3, 6, 9, and so you have the 674th group. Will have the 2022nd number. All right, so how do I match these groups now? I will take these groups according to the the multiples of 5. You know, that seems to be following a nice ordered set. So you'll notice that the third number is 5. The sixth number is 10. The ninth number in the sequence is 15. And you want to know what is the 2022nd number. All right. Fortunately, 2022 is a multiple of 3. Now, what's the general formula? We can say that the 3nth number, see, this is 3 times 2, 5 times 2, 3 times 3, 5 times 3. So we can say the 3nth number is 5n. See, if you put n equals 1, it works. N equals 2, you get 6th number is 10, and so on. So now we want 2022, and 2022 is 3 times 674. That number will be 5 times 674. See, the 3nth number is 5n. Therefore, that number is 5 times that. And that is 3370. It's very easy to multiply by 5. You simply halve it. If you halve it, you get 33. So put a 0 at the end. If it's an even number, and you have an odd number, you have 1 remaining, then you put a 5 at the end. All right, so that's the answer to that question. So there it is. You can see right at the bottom, you got 3370. Question 8. Find the smallest integer when multiplied by 123 yields a product that ends in 2022. All these questions were asked in 2022. Now, this is quite a challenging question, I must say. So you are looking at the smallest integer which when multiplied by 123. So we can, let's give a name to the integer. Let n be the answer to the question. So I need to, so that small integer is n. N when multiplied by 123, 123 times n, it ends this is quite a strange question. I must say, this is the first time I saw a question like this. So now you want to look for the smallest number. Okay, now as it stands, 123 times n, if there's nothing in front, this is not a multiple of 1, 2, 3. All right. So it's quite possible that there is a number in front. Suppose you say 1, 2, 3, n is say a 5-digit number. Like that, where m is a digit. That's quite possible. 123 times something can be a 5-digit number. It could be even a 4, no, it can't be a 4-digit number. Okay, so this, you can start with this. Now, it means now that n must be a 4-digit number. 123 goes into this exactly. Oh, and then n must be a 3-digit number. 123 goes into this part here. You put it underneath here. It goes exactly. So in this case, let n be a 3-digit number. So you've got, we can write this such a 3-digit number as 100A plus 10B plus C. Right? I usually write down a thing like this, but I don't put it this way because that looks like as if it's a product. I'll put a bracket around that. Its actual value is 100A plus 10B plus C. So you have 123 into 100A is equal to something, 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 2022. Actually, there's only one digit here. Okay, but it's not important. Now, I've got this 123, and I got a 3-digit number whose unit digit is C. And it ends in 2022. So what can C be? Right? You can see straight away, you can see that C has to be 4. Right? C has to be 3 times what ends in 2. There's only one number, and that's 4. Therefore, C is equal to 4. So let me substitute that inside here. I've got 1, 2, 3, times 100A plus 10B. I'm going to put this number which ends in this minus, I'll put C equals 4. 123 times 4 is 492. I'm going to take the 492 and put it on this side. Right? So it's 123 times this is equal to, you take the 123 times C, which is 123 times 4, and put it to the other side. What do you have now? You have something like this. I've got a subtraction sum here. 2022. I got 492. I'm subtracting. It's 0, 3, and here you've got 5, 15. Right? And you got something like that. Okay, so when you subtract 492 from such a number, it will land up with 1530. The last 4 digits will be 1530. Now you look at on both sides, you see that you got a multiple of 10. You can take out 10 or divide by 10 on both sides, and you have 123. Let me just put this. You see, n, I need to find n, right? So this last digit here is 4. We just got that. Now, 123 into 10a plus b, if I divide, so then I got 123 times 10a. Now, here you got 123. 10a times b is a 2-digit number, this one. And it lands, the last 3 digits are 153. Actually, last 3 digits. You got some other stuff in front of the 1. Right? Now, 123 times what gives you? If it ends in 3, it means that this number here, this number is b, by the way. 10a plus b, a and b here. Right? This is 123 times, this is a 2-digit number, 10a plus b. 3 times b ends in 3, so you will have that b must be equal to 1. Right. 3 times, if you take the units digit, b will has to be equal to 1. So now you have 123 times 10a equals 153, something 153. Now you said b is equal to 1, right? So I can take this thing and put it to the other side, and I have 1, 2, 3. 1, 2, 3 times 1, take it to the other side as we did before. And now you have some number, 153, and you got 1, 2, 3 here. So this becomes 3. When you subtract, you have 3, and you have 0, like that. So if I divide by 10 on both sides, I have 1, 2, 3 times A is equal to, and I'm going to divide by 10. So this thing here finishes off like this. So the last digits are 0, 3. Now A is a digit, you see. So A is a digit. It's going to be 1, 2, up to 9. And remember, it's the first digit of a 3-digit number. Now, 1, 2, 3, the only way this happens is A equals 1. Right? But then 1, 2, 3 times 1 is 123. That doesn't end in 0, 3. So according to this, I subtracted 1, 2, 3. So this means that it is impossible. A is equal to 1 now, you see. And 1, 2, 3 times 1 is 123. And that cannot end like this. So therefore, we said let n be a 3-digit number. It didn't work. So we'll have to try n to be a 4-digit number. And we're looking for the smallest. So there's no 3-digit number. So that n could be a 4-digit number. We still don't know. We might end up with an impossible situation like the way we did here. All right. Okay, let n be a 4-digit number. Okay, then you got 4 digits, which you're going to call A, B, C, D. So let n now be a 4-digit number. Then we can write n as 4 digits. All right, now that means that n can be written as 1000A plus 100B plus 110C plus D. Right? Now we proceed as before. You can see D is the units digits, and you got 123 times something ends in 2, so D will have to be equal to 4. Just keep this in readiness, which means that 123 times n ten C. Now I'm going to put 123 times n, but D is equal to 4. So this number which ends in 2022, you have to subtract 123 times 4. Just exactly as before. It's just that I've got extra things here. And this thing, as we saw before, the last 4 digits are 1530. All right? Divide by 10 again. It's almost a repetition of what we did before. So you land up with something which ends in 153. Right? I'm dividing by 10 on both sides. So 123 times C lands ends in 153. So we can say that C is equal to 1. So the last two digits are 1, 4. Right? Just to keep track of what we are doing. N is a 4-digit number. Its last two digits are 14. Okay, C is equal to 1. I'm going to take 123 times 1. I'm going to put it to the other side, as we did before. So you have this number, which ends in 153. You're taking 123 times 1, and you're putting it on this side, so you're subtracting. And this is 0, 3, 0. 1 minus 1 is 0. So you come up to the same thing. Some number which lands at 0, 3, 0. Again, you divide by 10. 1, 2, 3 to 10a plus b is equal to something ending in 0, 3. Dividing by 10 on both sides. Now, again, you have 123 times this single digit ends in 3. So the single digit has to be 1. And I'll do the same thing again. 123 times 10a. And I'm going to subtract. I'm going to subtract 1, 2, 3. Because it's 1, 2, 3. B is equal to 1. So it's 123 times 1, which is 123. Taking it to the other side. And I'm doing a subtraction sum here. So this is 0. Now you got the 0 minus 2. That's 10 minus 2, which is 8. You have to carry something. I'm not really interested in all these numbers. But what I do know that is that when you're subtracting this, you land with the 8 here. So divide by 10 on both sides. I'm going to just move in here. I don't want to take out all the pieces of information. So let's just create a little space here. So I'm nearly there. So A, when you divide by 10 on both sides, you get 123A is equal to something, 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 and it ends at 8. Right. So A must be 6. Now that's a digit, a single digit. 123, 3 times 6 would be 18. And this is not a 4-digit number. All my 4-digit numbers I'm putting in round brackets like this. So we have A equals 6. In fact, we've solved the problem. We had that B is equal to 1 and A equals 6. We wanted a 4-digit number. We got all 4 digits. So therefore, N is equal to 6,114. Okay, so that's the answer. And we can check to see whether 123 times N. Now you can actually multiply these two things. And I did multiply it, and I saw that the thing ends at 2022. All right. The answer will be down there because I did calculate this. Okay, so that gives you the, it's a very, very nice, unusual question. Very good question. What is the smallest number that must be multiplied by this to land up with 2022? Okay, let's just have a look at the answer. That we had. I'm not rubbing out. Oh, there it is. I can. It's hidden inside here. There's it. 123 times 6114. 752022. See, so it works. And this is the smallest number, which will end with that. All right, so let me just clear this thing. And this is really the answer that I had prepared beforehand for coming to talk to you guys. So we go on to question 9. A square wheel rolls without slipping along a straight level road. Okay, so it's got a very bumpy roll. It starts like this and it rolls and it comes to this position. Then it rolls, it comes to another position. Now, there's a small A here. That thing which you can hardly barely see is really A here in this corner. All right. Until it has completed one revolution. In other words, in the end, you want to have the situation where A comes back to its original position. That'll give you one revolution. If the side length of this square wheel is 1, how far does the point A travel? Okay, so you must be a little bit careful here. You just analyze this. So A is here, right? And now, suppose this is my road. Now, this thing turns around this point. So this whole line comes down like this. So you have a rotation until this thing here comes flat again. So you rotate it in a clockwise direction through 90 degrees. And when that happens, the A then shoots to the top. You have set this kind of a thing. So that's stage 1. Now, how far did A travel to get there? What is the path of A? And this requires a little bit of imagination, right? Because what's really happening is that you've got a rotation here. You got a rotation. This point is fixed, and this point A, as you turn it around, this A moves in the form of a circle until it comes to this point here. So we need to calculate this length because this is how far does the point A travel. So here, A in this, to reach this position here, let me just summarize this. To reach this position where A is now here, originally it was at the bottom. right? A moves through, well, A covers, I want to know the distance. A covers, right, this arc here. So this is a quarter of a circle, and you want to have a quarter of a circumference. The, these sides of the square is 1, so the circumference here is 2 pi r, 2 pi times 1, the full circle, radius 1, but this is just a quarter of a circle. So A travels this distance here, which is pi over 2. All right, so we are now at this position here. I just want to keep track of how far A travels. The first stage, it travels a quarter of a circle. Okay, now we are at this position here. A is here. Right, after it's went through a quarter of a circle. Now, we want A to come here. We want A to come here. Right. To do that, I still have to rotate. This wheel is turning, so I must turn one more. This part comes down here. This part here. But what happens to A? You see, when you turn this thing, A is sitting at the end of this thing here. So when the whole thing is turning, what happens is A, its distance from this point remains the same because you are fixing this point and you're turning it around. So A will still continue to be on the curve of a circle. It goes around like that, and then it comes. Let me see if I can put this thing next door. Oh. Yeah, now I've got this thing trapped here. I can move this. So what happens is that A comes to this point here. This whole thing turns and A reaches this point. Got A prime. So we want to know the distance it travels. But this time it travels again on an arc. And I'm just going to redraw this thing like that. So I need to know the length of that arc, right? Now, you see, this is a square here, and these are diagonals. So a diagonal is very important. comes up again later. The diagonal bisects the opposite angles of a square, the diagonal of a square. So these are 245 things. So this angle here is 90 degrees. And now you got A travels along this arc here. So I need to know what this distance there is. So it's a quarter of a circle. Why quarter? Because you got 245s here. This is 90 degrees. So it's a quarter of a circle, circumference. And the circumference of the circle is 2 pi r. Circumference is 2 pi times the radius. And the radius is this one. Now we have to calculate that. That is 1. This is 1. And the radius is square root of 2. By Pythagoras, the diagonal of a square is square root of 2. Whenever you have a square, and this is a, then the diagonal is always a root 2. A multiplied by root 2. Okay, now what is this now? This is pi root 2 over 2, because these 2's cancel. All right, now the third stage. Okay, so this the second round, this thing, I'll have to add this new distance. It's pi root 2 over 2. Right, and then let's take a deep breath and go back to the starting point. Just remove all this. I just needed that number there, pi root 2 over 2. Now, this is where we are. Now, at this stage, the A has come here now. So we moved from A, from this point to that point, and that point to this point. Right, now, I'm still rotating this thing. Now, a simple rotation through 90 degrees will bring A here. Right? And then again, A will travel to form a circle, a quarter circle, right? Because you're rotating this around. So the A will move on an arc like this. And just as before, we had pi over 2. So there's another pi over 2 here. This is exactly the same because you got a circle of radius 1, and it's quarter of that circle, just 2 pi r. Okay, so what is the distance it travels? It's pi over 2, and I've just put that in there. Okay, and then at the last stage, we are here now. I can use the space. So we are here, and uh-oh. So the A is here now. But I wanted A to be here. This is, I want to bring it, this moves, it has to move here. I have to tell you that I really struggle to see how can I get it there. The answer is very simple. All you do is you rotate it around A. And when you rotate this thing around A, then what happens is, you see, if I had B here, let's say that you had A and B there, right? Then the next round, you get A here and B is here now. Right? A follows B. In the third round, A is here, B is here. A follows B, and then this is what happens here. A is still following B, but this time you rotate it through 90 degrees around A. And then what happens is that the B comes to the top. So then you have the situation here, A and B. Because you turn this thing around, right? None of this is here, and the B goes to the top there, and this one here, it comes there and so on. All right, so, and this is exactly the original position. And the last position, A doesn't move at all. Right? Because you're rotating it around A, and you come back to the original position that we started off with. So this is 0. No motion from A. Okay, and then when you add these 4 numbers, you get pi over 2 plus pi over 2 is pi. We have pi plus pi root 2 over 2. Right, so that's the answer. This is the total distance that A moves. Right, pi plus pi root 2 over 2. Let's just check to see whether this is what I got. I do recall it something like this. Okay, let's go to the next slide. That is where I will have this answer. So there it is. You see, you got all these pictures and all that nice pictures. Right at the bottom. Pi plus pi root 2 over 2. Okay, that is exactly what I wanted. Okay, so let's get on to question 10. In the writing is rather small. I'll read it. A tortoise moves around on a checkered grid with unit squares by changing direction each time it reaches a new square. So as soon as it comes to this, it has to change direction. So the only way it can do is go up here. This here, you can either go that way or that way, but it maybe decides to go like this and so on. Right. So you can, but each time you come to move 1 unit, then the direction changes. Now the question is, what is the shortest distance it travels from A to B? From A to B on a 4x5 grid. This thing here is 4, as you can see, and that is 5. Now what is the shortest distance it has to travel to get to B? Now, I'm not going to draw all these diagrams all again. It's all time consuming. I'll show you what the shortest distance is. This is where it is. It's it makes a beeline. In this case, a tortoise line to this point here. And it doesn't move backwards, doesn't come down, moves up or forward. That obviously will give you the shortest distance. So what is the distance that it travels altogether? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. It's actually 5 horizontal plus 4 vertical. That gives you 9. Horizontals are 1, 2, 3, 4, 5. And verticals are 1, 2, 3, 4. Okay. So in this case here, the very first question is that it's a 5 by 4 grid. So this is 5 units long. All right, so the answer is 9. Now, they ask us question B, if the tortoise travels from the lower left, okay, that's where A is, lower left, to the upper right, same thing B, but you got a massive rectangle, you got 2022 times 4044. Oh, whoever said this question has got no sympathy for this poor tortoise. It's got 2022, and the other one is double that, 4044. Right. What is the shortest distance it travels? Well, evidently, it's going to go from A to B, but there are 2022 cells here. This way is 4044. Well, I think, again, once more, it'll make a beeline for this thing. Right, it wants to travel the shortest distance. So it'll just keep going like what I did earlier on, up. Like that, like that, like that, like that. And if you're doing that, you'll actually be covering the same number of horizontals as verticals. So you're going up 2022 verticals and 2022 horizontals. Right. You just add all the horizontals and add all the verticals. It has to change direction, you see. You can't go straight up there like that. So once it comes here, it must change direction. But it turns out that the distance you traveled is the same as that plus that. Because you've got 2002 vertical ones, 2002 horizontal ones. Okay, but now you're here, and you're going to get to this, right? And you have to change direction. There's only one way, that is down. Now you're still heading towards that, so this tortoise, clever tortoise. Okay, it goes towards it, And now it'll go up. And it makes that. But after 1 unit now, it comes to another square. It has to change direction. Like that until it gets to this. So now what is the shortest distance it travels? Once more, I'm going to resort to this diagram which I had, and there it is. So it goes up like this. It's 2022 here. I should have had dotted lines. Sorry about this. I can't rub it out now. So it comes up to a certain point. By that time, now from here, it'll go down, forward, up, forward, down, forward. And when you count this thing, you got 2022 things. Like if I had, say I had an even number. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. So if you got 6 spaces in between, 1, 2, 3, 4, 5, 6. With 6 spaces, you got 12. So here now, once it reaches this point here, you got 2022 spaces still to go because it's a 2022 by 4044. So there's still 2022 left there. And we saw that it's, like in this case here, it was twice the number of spaces. So altogether it'll travel 4044, which means that it travels horizontally for 2022 and vertically for 2022 to give you this. Okay, so in the end now you got 4 of these, right? Up that way, that way, that way, and that gives you 8088. Look, this is not drawn to scale. This unit here is only 1 unit. The whole thing is 2022. Okay.